Hello everybody, welcome to another Zabbix video. This time we are talking about server audit. How to audit your Windows Linux servers or workstations to obtain hardware information, software information. And in this video I'm kind of challenging myself how many common fields we can possibly aggregate and find about Windows and Linux. Use absolutely native functionality of Zabbix Agent 7, and we will formulate a nice table using the top hosts widget to be able to sort to see which server is having most memory, which is having the biggest disk attached, fields like that. Also, I'm very much target laptop audit as well. This tutorial can be used in case you have a bunch of personal computers at home. Maybe they are turned on once per month, but we can still obtain the information and store it in the inventory. And even if the server or workstation is turned down for multiple weeks, Zabbix will still be able to show the data in a nice table to represent like your equipment. Also, like if you want to see the outcome immediately, like check the timeline of the video. There will be chapters, like I will call it outcome. Check the chapter outcome to see if it's worth the effort. Otherwise, if you like the chapters, give this video a thumbs up, and let's start. And it's a public GitHub project available for everybody, and this is like a guidance how to enable, how to like implement this monitoring to gather the data and forward to the inventory, and all those what kind of fields it is capturing. It is available here in the index. We just click the button and we see here operating system, CPU architecture, and so on. So these are all fields which are common for the Linux and Windows. Let's try to implement this right now. And before I do that, I want to highlight that I am having 9 Linux servers, and some of them are x64-bit servers, and some of them are ARM64 architecture, and also one Windows server. Okay, and now, this is a nested template tree. We have one primary template which will need to be attached to Windows, and one primary for the Linux, and one template which will have common fields, like, for example, uptime is attachable to both Linux and Windows. So, but these templates are having 0 items at the moment, and we will implement one by one. Okay, let's start with the dashboard. That's my, to save the length on the video. Audit will be name of the dashboard. Click, and here we will select the widget, top hosts Monzphere. It is same as top hosts widget, but this one is allowing sorting on the fly by clicking on the title of the header. I will put some links in the video description how to install this if you are interested, but it will also work on this the default one, top host widget, as well. Okay, now let's put some things. Host group, agent 2, click, and now adding columns. Host name, this will be called host, add, and now following the tutorial I will add 12 fields, 12 custom fields. The first one, operating system, here, and we will access inventory field. Usually, most of the time, for the top hosts widget, we are working with the live data, but turns out this feature is not advertised too much, but I like it so much because accessing data from inventory, it's like a flat registry, and it has to be the maximum speed possible. Like if we design a table and read the data from inventory, it must be like the maximum speed possible to render all the data on screen. So yeah, awesome. Let's add 11 more columns. Text. Next one, architecture, and the inventory field is this. Add next one. CPUs. How many CPUs are inside that operating system? Either it's a Windows or Linux server. What kind of CPU model it is running? Click, and I'm attaching like a linkage to the inventory field, but after this dashboard I will actually only populate the fields. Memory. Click. What is the swap space? Or on the Windows computer it is the page file. Okay, disk column, and this will aggregate all the physical disks together. Like if it's a single disk or 2 disks, it will be able to like figure out like all of them and provide the size, like one number, what is the total size of all the disks together. Boot time, when the server was like restarted or booted up for the first time, not first time, but the last boot time. Online, this is entertaining to me. Like, is the workstation or server online right now? Okay, agent. What is agent? What's the version of Zabbix agent? No matter if we run agent 1 or agent 2, it is useful to me to always know like what are the what are the capabilities of Zabbix agent. And IP address, that's also was a challenge to implement, figure out what is the internal address or the first address of the first network physical network adapter from Windows or Linux server or workstation. Okay, the dashboard is ready and it's right now empty, but we will now design the template to populate all these fields, and like when the template is ready, after 2 minutes the table will be absolutely full, no empty fields whatsoever. Now to design the template, let's follow the tutorial. Operating system, so we are using native agent capability, starting with the Linux template, and this is an item key which is able to read the data of that file, and this will be master item, and since it's master item, do not store history. So the first textual data, and I will use this method throughout the tutorial, like collecting a bunch of data, maybe even too much data, because maybe too much data because with my experience I'm always like creating new solutions, and if there is already a master item available, I will use the same master item from this template. And if you are having this already, then great. All we need to do is create dependent item. So let's continue. Dependent item, inventory, operating system, the item key. Click. This will be string type of data, and again we will not store inside the historical data. We will forward only to the inventory thing. OS short, and inside the pre-processing, regular expression is the thing here. Extracting group 1, add. So the Linux solution and operating system is job done. Let's implement the Windows as well, and soon I will open the table to see if it's even working. Now the Windows solution, it relies on the VMI query. Here, this is a native key supported since Zabbix 6 in with the maximum minor version, or in the Zabbix 7.0. Okay, this is the master item. Will not store anything, add, and for the master item, create dependent item. And this master item will be used for more dependent items throughout this solution. but this time we are extracting operating system only, character, not storing operating system in like not having any retention. I forgot to forward to inventory, OS short, and the pre-processing must be done from the JSON path. Click, and now let's highlight a little bit what this VMI query is doing. This select star from Win32 operating system. Let's have a look here. So what it reports, this is JSON, and it's coming from the Windows, and there is a field which is called caption, I suppose, or let's what was the name? Caption. Yeah, if I do caption, and here you go, like this field is dependent item, and creating more dependent items we can extract any other field which it looks fancy to you. Let's continue. Add. Now the operating system is completed for both flavors. Let's check up with the table if it's even working. Dashboard. For the Linux, not yet. I will still proceed forward. Maybe it's not enough time. And let's go forward. Next one, CPU architecture item, and here we have native item key. System.uname. It is reporting very similar stuff as we run uname and a. Like this is the raw data from that item. And okay, we will not store data for this. Add. And this item key most likely exists already inside the template. Okay, but creating dependent item. Just to deal with this inventory, click. So this will cover the architecture. It will extract either it's a 64-bit or ARM 64-bit, or maybe the old 32-bit system. And this has to be character. And we will populate this to hardware architecture, some field which looks very similar. Okay, and the pre-processing is JavaScript. And what it does, it is looking on here, like we see inside this line, there is x86-64. If it finds, then it will report this very keyword. If it finds something else, like Arch64, that's like ARM type of architecture, and it will have these strings inside the outcome. Okay, add. Now let's go forward. Implement for hardware architecture and CPUs. Okay, yeah. Next item key architecture. Did I implement for the Windows? Let's see. Click. And where is the tutorial? Architecture. This item key is for both for Linux template and Windows template. So let's I'll do a little bit patching here. We will remove the we'll remove the architecture. Click update and forward this uname. Copy to template audit OS. Click copy, and copy also this key. Copy to template audit OS. Copy, and it's also, I think it's mapping immediately. Yeah, the audit OS, it's having two things, and now it is able to query the data from both from Windows and Linux operating system at the same time, because it's having common thing. Okay, let's go to the next step or check the table. Nothing is there. Okay, now welcome to troubleshooting session. The operating system should be populated so far, and let's see what I'm targeting here. Inventory OS short, save, and when we check what kind of data actually comes, agent 2, click, apply, and checking the inventory field. The inventory is it is currently to the manual mode. That is the reason. Data collection hosts, what I need to do is select all, must update, inventory, click automatic update. Okay, let's continue the template development and going forward. The implementing CPUs, going to the Linux, create item, copy, click CPU info, and do not store the historical data. Now dependent item here, and the name is CPUs. The item key is this. This is integer. I do not need to store this information, and I will store this in a serial number A. Okay, and it needs pre-processing. Okay, and this is JavaScript. Okay, what this pre-processing is doing is, like, we have a file proc CPU info, and inside this file there is a keyword processor, processor 7, processor 6, and so on, and it is counting how many lines start with the processor, and that's the amount of processors on a Linux computer. And when it's ready, then it stores in the serial number A. Okay, let's implement same for Windows. Click create item. Following the tutorial, the Windows relies on a VMI query again, and we will not store it. This is master item. Now from the Win32 processor, dependent item, and this one will be inventory CPUs, and this is integer. We are not storing, but we are storing in serial number A. And here the pre-processing will be interesting because it is having there are threads available, and there are number of logical processors. Let's see how it looks inside the here CPU. Number of logical processors 12, and also the threads somewhere inside the alphabet. And if we have a very old hardware, then those old hardware does not have threads, they have only processors. That's the reason we need a fallback scenario. If this field is not available, or the script is saying, if thread count is available, let's see here, thread count 12, then report this one, otherwise just report this other field. So it's having a backup plan. I tested with some old hardware, and then it works so much better if this logic is implemented. Okay, add, and now the table should have at least 2 columns, and here you go. We have operating system. Let's put in a full screen, and we have how many fields? 20. Apply, and since CPUs was implemented just a few seconds ago, then it is here. Okay, architecture was also implemented, but still not reporting. Let's have a look why it's not working. Data collection, templates, click, and this is a common item key, and click, and uname, this is the input item, character, and apply. And does it, if we open those Windows computer, okay, it's not failing at this stage, and I think it maybe need time. So let's proceed with the next implementation. And the next implementation is CPU module, just for the Linux. Click, create item, CPU module, this is the one, active check, proc info, click, this is textual data, we will not store it, add, this is already exists, so that part needs to be ignored. We need just to create dependent item, click, CPU module, model, and not storing anywhere, and forwarding to model. Okay, and the pre-processing for the model is JavaScript. Click, click, apply, and this must be character data type add. Implementing same for the Windows. We will rely on VMI query. The VMI query already exists, so creating dependent item. This is the CPU model. Click, and this is character data type, inventory model, not storing any history, just only forwarding to the inventory field. Okay, how about that architecture? Is it working? We have architecture here, it is not working. Hardware architecture, okay. This is common inventory field, and CPU, it looks like I made a mistake to forgot to add JSON path on the Windows. Click, and CPU model, where it is, inventory CPU model, click, and CPU model, and the JSON path is this JSON path, add. Okay, next implementation, total memory for Linux. Click, we have we don't have mem info. Click, active mem info, and this is the master item, adding just as is, and then dependent item. Dependent item will extract the bytes of the memory, and we will not set the units, because inventory, if we set units, inventory will sort it alphabetically, and I prefer to just still sort which server is having the most, like the biggest amount of memory. Okay, and pre-processing is regular expression, like this, and it must be stored to the field. Here I'm using a little bit random field, phone A, primary. Add. Okay, that's implementation for Linux. For the Windows, click. I forgot to add the multiplier. Memory memory, total memory, here you go, click, we are extracting, and we have to multiply by 1024, update. Now implementation on the Windows computer. Do we have physical memory? No, we do not have. Need to create another item. Click, the name will be this. This is the master item, not storing history. For that, creating dependent item and calling it like this, and the key is that, not storing, and this is phone A, and some fancy pre-processing to aggregate sum of all of the disks together. Okay, add. Let's check the table, how it is doing. The architecture is still not there, but other stuff is coming. What could be possibly the problem? Architecture, templates, OS, let's just and it's not working for like, it's not really working for anyone. System uname, here every 1 minute it is executing the native item key. We are not storing anything, we have a dependent item. This is the mistake, I am not forwarding. Okay. Hardware architecture. Okay, job fixed. The problem fixed. Let's go forward with the next implementation. Templates and memory total memory. Going into the Linux template, and we have mem info already. All we need to have is create dependent item. Click. Wait a second. This is swap file. Okay. Creating swap name and item key. Not storing anywhere, but forwarding into the inventory, which is called phone B. Add. Okay, swap is covered for Linux. Let's go to Windows. Click. Windows rely on the operating system VMI, this one, and it's already there. Click dependent item. Let's call it like this. The item key, this, not storing, and forwarding in the phone B. Multiplier is missing, and maybe I forgot that to be included inside the Linux. 24. Add. Let's check if the Linux was good enough. Click. And total swap here. Aha! Dependent item not having pre-processing. Oh me. Total swap. Add. Click. And the pre-processing is this. Extracting group 1 and multiplying by 1024 because this is kilobytes. Okay, and still forwarding to the phone B. That's excellent. So far we implemented also for the Windows. Next chapter, disk utilization. Disk. What's the disk size? On the Linux system, we are relying on this file proc partitions. Click and let's add. So it's running. Okay. Now creating dependent item. the name will be this, and item key, and we will not store it but forward to the inventory. Phone A. Okay. Yeah, and then the fancy pre-processing rule, which is using JavaScript. Click. Let me explain like what happens here. It was there was bunch of development put in this thing. Like this is the file, and we can read this file with the native capabilities of Zabbix. And then the second column, if it shows 0, then it's some sort of root object, like the real disk object or the disk massive, or here root object is CD-ROM. And what it does, the JavaScript preprocessing is looking where the second column is 0, and then filtering out only those lines. And after that, we will have more preprocessing, which is like filtering out what kind of objects to ignore. The JSON path also supports negative lookup, which is looking like where the disk is not starting with the SR or not starting with the loop or disk massive. Then it will like report those lines. And then we are doing also total sum of this thing. Okay, and also multiplication because it's a kilobytes. Click 1024. Okay, and forwarding to phone A, add. Okay, and on the Windows computer, click and Windows, create item. This is native item key. Wait a second, this is this disk drive is for the very first time. Not storing history, add. And now disk drive deserves to have a dependent item. Dependent item will be inventory disk and item key, like that, not storing history at all, and storing in a secondary phone A. That's everything. And pre-processing is let's open the raw data for the disk. Like this is the stuff agent is capable to report in a native way. Like even like the disk model is there, but there is some other disks, like if we plug an USB device, it will discover those, and I want to ignore those type of systems. And all we need to have is like, I would like to extract the size, but ignore all the external stuff which is attached to that system. Okay, and because of that reason, we need these JSON paths, which also use negative lookup, which is looking when the model is not Microsoft disk, and if interface type is not USB. Okay, and then if it's matching this guy, then it will just extract the size of all the disks together. No, it's not extracting all disks together, but yeah, it can use a very similar approach as the other one, like size sum. Let's skip this for now. This JSON path is reading the very first physical disk on the Windows computer. It's a kind of a mistake here a little bit, it will not be accurate if the disks, if the Windows computer is having more than one disk. Okay, let's where we are storing secondary phone A, add. Now the next chapter, boot time. and this is exclusive item key for the Linux. Create item key, active key, system boot time, and we will call it boot time, not store it, and okay, that's everything for the boot time. Add, and for the boot time we are creating dependent item. First dependent item will be showing, like, extracting human readable time, and I could kind of use this one numeric Unix time, but it is it will be a how to say, I want to have a memory, I want to have a historical data of when exactly was system booted, like all the occurrences in the past, and then I choose to use this, and okay, and this will have retention period, and click, and JavaScript, and okay, character. Yeah, let me back up my reasons. The reason why I'm storing as character is because I'm using the cron job to defragment the characters table. Every night it looks for repeated values, and it will delete repeated values which is consequent, and this allows me to store stuff as character. Like if it boots like once per year, then it will have evidence inside the table, and if we have like a lot of restarts going on, it will show all the restarts exactly, not with the repeated values. If you want to find out more, then check the other video in this channel, which is called Discard Unchanged in Retrospect. Okay. Okay, add, and this pre-processing step, I mean this dependent item will have another dependent item. Click here, dependent item, and this will be the real stuff, boot date, and boot date, copy, and let's send this to date hardware installed. Okay, and this one will just extract the year, month, and day. The previous one, it will extract also hours, minutes, like exact boot time, but inside the table I want to see just the date, the month, and the year. And this is character data type. We are not storing historical data. Add. Now the Windows solution for the boot time. Click boot time, click create item, operating system, we have already that key here, operating system, don't need to create it anymore. Create dependent item, inventory, boot date, click, and that, and not saving at all, and I will forward to date installed. Okay, and the pre-processing is JSON path, and here this one also exists in that JSON, like we are querying operating system. If we search, we have boot time. This is how Windows tells when exactly the workstation or server was booted, and the dot is missing, and I would really like to have a dot, and like here extract first 8 characters and add some extra pre-processing. and that's the reason we will use this regular expression. Click and extract the group 1, 2, and 3 and have a dot in the as a separator. Okay, add. Need to follow up with the table if it's even working so far. Let's put on the full screen, and this is the solution so far. Like sortable operating systems, architecture we see, how many CPUs per Linux and Windows, what kind of CPU module is, and this is special code like the ARM64 architecture is using. We can Google around like what is this exact CPU module. I tested this with Raspberry Pi 3 and 4 and also in the cloud when the server runs with the Arch64. Total memory, total swap, which servers is having like completely swap off, and yeah, total disk size, boot time. Okay, and now let's complete the last chapters, templates, and next one is the system right now online? And this is a common item key, items, create, and we will call it system uptime. And this already exists in the Windows and Linux template, so you would not need to create this, but we will need to create dependent item. I will not store the historical data. No, sorry. This needs to have historical data for sure, because we will rely on the uptime metric to find out is the system online at the moment. Add and create item and create calculated item, and the calculated item will it will be called like is online, and item key is online, and it will use the uptime data, and it will count how many metrics, how many samples we have received in the last 91 seconds, and it has to be at least one sample, and if it's there in the last like 1 minute and a half, then it will kind of treat the server as online at the moment. Okay, let's add this to deployment. Deployment status. Do not storing history, and I will add the discard unchanged pre-processing. Like this is dangerous to like every 1 minute to forward the stuff to the inventory. Like all the other keys I made so far, they are also dangerous, and it is suggested to have it to query the VMI stuff every 1 day or every 1 hour. I will change that at the end. But this is super dangerous. If we have thousands of servers, then to forward the current state, we have to have this discard unchanged. Okay, also value mapping. I made one already in the template online. If it reports 0, then it's online no, or if it's 1, then it's yes. And the magical pre-processing, there is actually something required, JavaScript, and so what it does is looking if reported number is bigger than 0. If yes, then report 1, and if it's not bigger than 0, just report 0. And this will guarantee the substitute. This will guarantee for the value map to work. Okay. Add. So that's this common item key. Next one, let's have a look. The next one, implementation also, it's a common key. Zabbix, the version of Zabbix agent. Okay, create the item key, and this already exists on the Windows template, so if you try to implement, then you don't need to create this item key. Agent version, and here it will not be stored. It's not mandatory. Add, and what did I click? Create and active item agent version like this, and not storing. Add, and add another item, inventory and agent version sortable, and there will be some interesting things happening. Populate this to the inventory field, primary POC screen name, click, and the magical pre-processing JavaScript, click, and like the last minor version, if it's okay, I will explain in the dashboard. Like, to make the agent version sortable, we better add the last minor version, like extra 0 at the end if the number is smaller than 10, or if it's bigger than 10, then do not add the number. But if it's smaller than 10, then add the extra dot. So alphabetically we can sort the versions inside that table. Okay, character, do not store, forward there, add. So this is common item key for both Linux and Windows. Okay, now the last column, IP address. Going here, and Linux, we will read the IP address from this file, so it exists on all the Linux systems, and not store the historical data. Add. Now creating dependent item. Cool. This one, inventory address and IP address, character, and this will be forwarded to out of box IP address, not storing any retention data, pre-processing, and the JavaScript pre-processing. Okay, this I'm not so proud, but like I'm coming up with the algorithm which match my environment. And first of all, the IP address was character. Let's save this file. Add. The IP address is coming from this file. If we check the file, enter, like this is the content. Let's clear the screen. Like this file exists on every Linux system, and it will contain the same IP address we do see inside the IPA. Like somewhere this Ethernet we see 88.56, and this file also contains the IP address. And it's not so easy to extract, and so I came up with algorithm which fits my 12 servers or 10 servers or workstations, and my algorithm was to ignore anything which looks like IP address and starts with 127 or starts with 169 or ends with 255, ends with the 254, or ends with the 0 or 1. And apparently it is like everything is accurate, and I will improve this algorithm once it fails to detect the IP address in my infrastructure. Otherwise, like I would say it is like this can exist in, I think, in the real life, which ends with the 254, but not in my environment. So that's the reason I am using this JavaScript pre-processing. Okay, and let's cover the IP address for the Windows system. Windows IP address relies on the new item key, create new item, and active item. It is VMI registry, and this is text to all data, not storing the data at all. Add. Okay, and now dependent item. Where is my master item? This one, dependent. The dependent item, this one, IP. This will be character, not storing data, out from box IP address, and pre-processing, click, and JSON path. I tested like this thing was not working on agent 2. I cannot explain. It was not failing completely. Like it was with agent 2, this part was working, but for some reason it was not recognizing that thing inside. Like the agent 2 was working differently on a Windows computer. With agent 1, it was able to detect this thing. All the other things in this tutorial, all the 11 other fields was working fine with the agent 2, but with my setup it was for some reason not working. Okay, add, and this was the thing, the last bit for the table. Let's put in the full screen, see how the dashboard looks like, and this is how it looks like. The Windows is not yet coming. Maybe someday it will arrive. Okay, so yeah, what we see here, sortable fields, and now like sorting by memory, like when we store inside the inventory these numbers, it allows to sort it. And what's interesting and exciting to me that even if we unlink all the templates, like the host object without any template, this template, this table will not be deformed. It will still exist and recognize, because practically we store everything here inside inventory. Like this is a flat registry. Everything is stored in the inventory. Okay. Now a bonus video, like it is still possible to convert these bytes to more human readable. Very interesting workaround, and what we can do is create template, like create another template which will be called audit operating system, and like maintain, something like that. Add, and this template will read those three fields, 3 columns, which is like too long and not so easy to understand. Okay, items, create item, and script item, and now let's follow the tutorial from here. Convert bytes to human readable. Create script item, inventory total, click, and the item key will be that, and the argument will be this, and the field will be this, and the pre-processing, the actual script item, that. So the script item turns out to be able and capable to read inventory fields, which is super exciting to me. And now we can read that bytes from that thing, and even if it's not running the collection. The reason why this, the reason why I am using this, because I want to audit those like workstations or laptops, and then turn it down, like turn it off and not use it for a month or so. And then it's mandatory to store the total memory, total swap, total disk in the inventory as a bytes. And these 3 items will allow to still generate the table with a very good looking data about memory, disk, and swap space. So let's see how it looks like. Here we will store only history, not forward to the inventory anymore. Add, and I will clone this item multiple times. Add it like swap, and here the item key will be this, and the phone is that, and that's everything. Add, and another clone, the last clone. Click, and inventory disk, and this one needs the phone A. Okay. Add, and now we can make a beautiful table, but before that I need to link the template on the objects. Gen 2, click apply. Let's put in the full screen. Selecting all objects. Here I'm selecting Windows and Linux objects. Okay, and mass update, link a template, maintain, click update, and now dashboards. I can remaster. The IP address for Windows also works fine. Great. What is with the swap and boot time? It looks like the OS metric is not so working at the moment. Okay, let's put the replace. So memory, RAM, what we can do is here pick up this data, we pick up the item, and add, like convert back to normal item. Click and that, and here 0, and update. Now the swap is this item, click, and 0. Okay. Update, add, edit, and this disk item, like item value, click, and 0 decimal points, and update. And voila, now the thing is more beautiful. Like we see RAM in gigabytes or megabytes, we click and it is sorted. Again, like I will repeat, this complexity is because I want to keep some certain equipment offline, and then if we keep offline, then it will fail to read the data. But just because the data is already stored in the inventory, this script is reading inventory, then I can completely shut it down and still able to render the table always. Okay. Then let's. This is the outcome, and what we have here. Maybe let's fix that thing. Why the Windows is not working? Templates and Windows items, and we have this is the master item. So the best practice is items, and we have a lot of 1-minute items. Let's select all of them. Not all of them, but most of them. OS release, uname, CPU info, mem info, partitions, boot time, that can be fine to run execute 1 minute. Inventory is online as well, fine. But these ones must be with a smaller frequency. Update interval, like 1 day. Update. That would be like how in the production it should look like, to not overload the database. because these are collecting texts and the traffic will sacrifice, like the proxy will be overloaded. All the other ones, like 1 minute, this is reporting one line, this is reporting integer, this is required to calculate every 1 minute. Let's visit the common template. Common is this one, and here uptime needs to be run every 1 minute. Uname, this is not necessary. One day update, and agent version as well, like 1 day. Inventory is online, like this is important every 1 minute, and uptime as well 1 minute. And for the Windows, click, and we see like these dangerous things: Windows, processor, memory, disk. So this will take a lot of throughput, not a lot, but if you have hundreds of servers, then it will be quite a lot of throughput. Then we have to lower down the frequency. This is almost good enough. Must update interval 1 day. Okay, and it was not this operating system was not working. Let's set up the scheduling, like every time where there is second 15, let's manually execute. And right now for the operating system, like let's enable the history. Maybe I will figure out like why it's not working. Click operating system, click, going back to the dashboard. So I'm troubleshooting this why the field is blank, and let's click on here, go to the items, and we see something is not working. Click. It looks like the data type is not correct. Absolutely. Yes, the JSON path is missing. Click. This is the swap file, swap page file, and click, and it's missing the JSON path, I would say. Click and add JSON path. If I would follow my own tutorial, then it would work much better. Update. So swap is completed. This will recover very soon. Inventory swap will work as well. And boot time, maybe that is also missing the pre-processing. Click. Last boot time. Why I'm storing it as an integer? It has to be this character. Update. Okay, it will recover very soon. Script, that's already. Click. So for this workstation, operating system, click. It will recover in the next 1 minute. Dashboards, and boot time is the last missing field. Let's count. Click, refresh. And what I wanted to tell more. Refresh. Yes. Okay, let's fix that thing. Windows template. And boot operating system, like this must go away every 1 day only. Okay, update. So I will show also unlinking the templates right now. Like it's possible to unlink most of the templates like here, select everything, must update, and link template, unlink, and here like Windows, audit OS, Linux, and audit OS Windows. Okay, and let's unlink and clear, update. And now it remains like only the script item is there here, the script item, so it does not reach out to the equipment. What are these 45 items? Okay, that's not related to this tutorial. So nothing is running here anymore, like there is no memory monitoring, no, like nothing. But if we go back to the dashboard, the table is still there because everything is stored inside the inventory. This is the outcome, and it works because all the data is stored here. If we open the host, like here maybe there is almost no templates, or this single template is responsible about maintaining the data about memory, swap, and disk. And the table works really with these inventory fields. They are there. We can choose to keep the Linux and Windows template 24/7, or if we unlink, then it will still work. Here we can sort by operating system, sort by architecture, sort by how many CPUs for server, what kind of CPUs are there. I personally like implement like mapping here as well for the ARM64 architecture. Sorting by memory, we can see sorting by swap space, which servers or workstations having the biggest disk, what is the boot time when it was last restarted or booted, is the station online right now, and this online should kind of go away in the next 2 minutes because there is no uptime metric anymore, which generates the kind of heartbeat. Sorting by agent version is possible, and listing the IP address over here. Alright, that is everything for this video. If you find it helpful, give it a thumbs up. Also, the links on that GitHub project is inside the video description. Thanks for watching.